Every year, Try Hack Me counts down to Christmas by running Advent of Cyber, a free series of guided challenges that will teach much more than just the basics of cybersecurity. Today, we're digging into SCADA, PLCs, and Modbus, all with everything explained so you will understand even if you never heard of them before. For every day you finish before December 31st, you get a ticket to the prize draw. Let's look at the prizes this year. Cool hardware, Flipper Zeros, DEF CON tickets and certifications. Oh, and a lot of free subscriptions and swag vouchers from TryHackMe themselves. Cool. And if you missed previous years, they are still available. Just search for Advent of Cyber. Ooh, here they are. 2019, 2020, and all the other years. Lots of easy access knowledge. This is, by the way, the perfect spot to look for all rooms that are free. 55 pages. That is 651 free rooms that you can play around with. This is one of the things I love about TryHackMe. To find the advent of cyber, we just click AOC at the top of the page. And of course, I'll put a link in the description. Here we have today's room. ICS Modbus. Close for concern. Learn to identify and exploit weaknesses in ICS systems. Let's get started. The snow falls heavily over Wareville as chaos erupts at TBFC headquarters. What should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg? Shouts a frustrated warehouse worker holding up yet another Easter-themed package. We're supposed to be shipping Christmas presents. The delivery drones buzz overhead, their mechanical hum sounding almost mocking. Each one returns from its road empty, having successfully delivered its cargo, but the cargo is all wrong. You're called into the command center, where screens flicker with delivery statistics. Everything looks normal on the surface. 1,000 presents in stock, 98% success rate, and all systems are operational. But the phones won't stop ringing, with confused citizens asking why they are receiving chocolate eggs instead of the toys and gifts they ordered. The statistics manager pulls up the delivery manifest. Look at this, she says, pointing at the screen. The system indicates that we delivered a teddy bear to the Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but it's completely different items. Then, on the monitoring screens, a message flashes for just a second before disappearing. Exploit 6.66. Property of Hopsick Island. Why should Christmas have all the fun? King Malheur. Someone has compromised a drone fleet's control system. The attack is sophisticated, falsifying sensor data, manipulating inventory selection, and erasing old traces. This isn't just a prank. This is a calculated assault on Christmas itself. Your mission is clear. Investigate the TBFC drone delivery system, uncover how King Malhair's exploit team has compromised it, and restore Christmas deliveries before Suckmas is ruined. But be warned, King Malhair doesn't leave systems undefended. Traps are waiting for the careless investigator. One wrong move, and you might make things much worse. A mysterious discovery. As you walk through the warehouse control room, something catches your eye. A crumpled piece of paper on the floor near the PLC terminal. It looks like someone dropped it in a hurry. You pick it up and unfold it. The handwriting is hurried, almost frantic. TBFC drone control. Register map. For maintenance use only. Holding registers. Package type selection. Oh, Christmas gifts, chocolate eggs, Easter baskets. Delivery zone, normal ocean dump. System signature version 100. Question mark, question mark, question mark is the current one. Check this. Coils, Boolean flags. Inventory verification, protection override. Emergency dump protocol, dump all inventory. Audit logging, Christmas restored flag. Self-destruct status, Critical. Never change HR0 while C11 is true. Will trigger countdown. Maintenance tech December 19th. Oh, today. What happened? So C11 is protection override. Changes locked monitored. Ooh, that's a true value. And HR0, package type selection. So we cannot set this back without setting this one first. That's good to know. You stare at the note, confusion washing over you. Register map, coils? What is all of this? The terminology is foreign. HR0, C11, Modbus scribbled in the margin, but something about this feels important, like a key you don't yet know how to use. You pocket the note carefully. I'll figure out what this means later, you think. For now, you need to understand the systems you're dealing with. Little do you know, this crumpled note will be exactly what saves Christmas. Oh, let's actually save this data into our notes. It seems important. Let's save this here. So, now we know what the problem is that we need to solve today. And here we get the information about what we do to access the systems. We're going to start the attack box, or if you have your own VM and VPN, you do that. And we need to start a machine on here. So let's start the attack box and the machine. But we have some reading to do before we get there. I'm going to view this in full screen to get a whole separate window with the attack box on, and then we can easily control tab between these. And then we close this one down, so we have it on our separate screen. The machine is starting, and the attack box is off. Let's answer the first question. Plug a second investigator. Christmas is hanging by a thread, and only you can pull it back from the brink. Now, we need to know a lot of basics before we can dig into actually talking to the SCADA and PLC systems. Today, we're going to learn to identify and exploit the weaknesses in ICS systems, industry control systems. This means systems that control, for example, manufacturing, power grids, water, and other infrastructure. This is something we want really secure, especially in our times, right? We'll learn about SCADA systems, PLCs, and the Industrial Communication Protocol Modbus. SCADA is a system that provides a centralized interface for monitoring and controlling an entire industrial process, like a water treatment plant, factory, power grid, a system for sending out Christmas presents. So it collects real-time data from devices, sensors, and it moves actuators. So sensors and actuators here. This is the sensors, eyes and ears, and the actuators are like motors and things like that. In this case, it says sensors detect when a package is placed on the conveyor belt, and actuators control the robotic arms that load drones. Then we have PLCs. When an operator of the system wants to send a command, the thing that gets this command and actually does things and actually send the command to the actuators are the PLCs, the programmable logic controllers. But the PLCs also take decisions themselves. For example, if one part of the conveyor belt would stop, it might send a signal to a PLC in another section saying, stop, 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 or we're gonna get a massive pileup. So they're smarter. It's not just a motor or a sensor. So in this case, the PLCs, if the packet weight matches a chocolate egg and destination zone 5, load it onto drone 7. Monitoring system, we also have a CCTV camera feed here that we will be able to watch. You can also have dashboards and alarm panels where we can observe what's happening. Then we have the historian's logging of the system.
It can log what packages are loaded and drones that are launched and system changes and so on. And here we have the same information that we got on the note, approximately. And now we get into the security flow and all of this. So these systems used to be run over serial wires. Now we run them on networks connected to the internet. They didn't used to need security in the same way. Security didn't exist, right? Back then, long ago, 60s, 70s. And because of that, there's no authentication, there's no checksums, there's nothing really. And where there are credentials, they might be default credentials. PLCs are not what is updated because they are supposed to be started and then they're supposed to run forever. You don't want the water plant to suddenly stop working, pausing everything, and yeah. In early 2024, the first ICS OT malware, Fuzzy Goop, was discovered. The malware can directly interface with industrial control systems via the Modbus TCP protocol, enabling arbitrary reads and writes on devices over TCP port 502, which is the Modbus default port. King Malhare has weaponized these same tactics, not to cause blackouts, but to sabotage Christmas deliveries by directly manipulating the control system through the Modbus protocol. What port is commonly used for Modbus TCP? 502. Let's get a little deeper on the PLC, the programmable logic controllers. They're very basic computers, but they are programmable. The main point of the PLCs are that they are extremely reliable and can take harsh conditions. They can operate 24/7 for years, sometimes decades, without rebooting even. We can't afford downtime for software updates or system restarts. When it starts running, it's expected to keep running indefinitely. What is Modbus? Modbus is a protocol that we use to talk to the PLCs. In this case, the client is our computer, and it might ask, what is the current value of register 0? And the PLC, which is a server, says register 0 currently holds a value 1. These PLCs don't have a lot of data types. It is just for inputs from our side where we can put data. These are what is called as digital outputs from the PLC's point of view. This is a motor running, meaning do we set the motor to run or not? Open, close valve, and alarm active or disabled. So setting stuff off. So outputs might sound like it's nothing we can input there, but it is exactly the opposite, unfortunately. And then we have discrete inputs. These are sensor information and things like that. Things we can't change. We can't change the temperature by changing the sensor value. And then we have these two versions, but instead of just a true or false, 0 or 1 value, we have more data space. We can also use several of these registers to keep one value with more detail. And again, the holding registers, what is called outputs here, are where we can input data. We can set the temperature point. We can set the motor speed or the zone selection. We cannot set the current temperature, pressure reading, flow rate, because those are sensors. So it's easy to flip these around in your head and think that outputs are where we output stuff, but it's the opposite. So the places we need to put data is the coils and the holding registers. Let's quickly flip back to the data on the little piece of paper. We saved it. Here we can see HR. Oh, holding register. Okay, and we don't have just a true false value, but we have actually 3 values here. So now we know why this is the type of data to set there. Then we have holding register 1, delivery zone. Okay, so this uses 1 to 10. And holding register 4 is the signature. And then we have C, the coils, the binary Boolean flags. Yeah, so we have all the information. So now we understand a little bit more about the information we got. Nice. Yes, they have made a little list of it here too. And we notice that the holding register 0, it starts on 0, not on 1. Here it mentions that it used to be serial, but that we have enormous benefits of it now using TCP. We can monitor remotely, easier integrate with business systems, and centralized management. You can also see the history, but this exposes it to network-based attacks. Focusing in on the security problem here. No authentication, no encryption, no authorization, and no integrity checking. So it's just a TCP checksums. So nowadays, of course, we add as much security as we can. VPNs, firewalls, Modbus security gateways, trying to make sure that port 502 is not out there. The note you found, the maintenance technician must have discovered what was happening and started documenting the compromised values. The warning at the bottom, never change HR0 while C11 is true. Suggests they figured out the trap mechanism before getting interrupted. And we are going to use Python and a library called Modbus to investigate the system and control it. Now that you understand how the system works, the mission is yours. Hack it back and save Christmas. So we're going to start investigating using our attack box machine that we have started. So now it is time to Control Tab to our attack box. Let's open terminal. So it's time to do some initial reconnaissance. Let's copy the IP address of the machine from right here. Control C. And then I'm going to hop to my other tab where I have the full screen attack box using Control Tab. And here we're going to type the nmap command. Nmap ports 80 to check if there's a CCTV there, and comma 502. And no spaces. 502 is the default port for Modbus. And then we want to check what versions of software are running on these ports. And then we need to paste the IP address. But to be able to paste it, we need to put it in the clipboard of the virtual machine. So let's paste it here. And then we can Shift Control V to paste it here and run the command. So this is just because the attack box don't seem to have a etsresolve.conf file. So just ignore these lines. When the scan is finished, we're going to run a scan of all ports while we continue exploring. There! So we have service fingerprints and things here that we can check out. Let's scroll up to the start and read all the information after this DNS warning. So nmap scan report for our IP address. We have port 80 open and Verxog 313 Python 3.12.3. So something is running here using Python, and we have 502 open. And we also got a little fingerprint information here from port 80. So we can read get request. Yeah. So it is this that it says there at the start. We don't have to read all the details. We are going to actually check out this web page. But first, let's start a new scan. Let's take this one up and replace these ports with a dash. So we have dash P dash. That means all ports. Now let's go up to Firefox and go to the same IP address using the browser. We're going to type http:// and paste the IP address that we have. This will automatically go to port 80. So we have a status compromise, disarmed. And we can see there's eggs everywhere. All we see are eggs, eggs, and eggs. No Christmas presents inside. So we can use this to see if things are working as they should. The next step is to send Python commands to the machine. Let's hop back to our terminal and make a new tab by clicking Ctrl-Shift-T. Let's Ctrl-Tab back to try Hack Me. And let's scroll down and look at the next section. It's time to do the Modbus reconnaissance. If you're using your own virtual machine and not using the attack box, you will need to install PyModbus using this command. As it's already installed on the attack box, we can just continue. The first line that we will use in all of the Python code that we write is from PyModbus client import Modbus TCP client. This means that we will be able to use the Modbus TCP client Claus to connect to port 502. The first line here is to connect to the IP address and the port of the machine using this and make ourselves an object. I think the easiest way to do this is to copy all of this text in one clump. We can do it exactly like they're doing it here. Start Python, get the Python prompt and type the text. But as it is a bit complicated to copy text into the attack box, I'm going to make this into a little script instead. This is how we will end up later anyway. Let's start Nano, a very simple text editor in Linux. And let's call this one script1.py. Now we're going to use the paste here and clear the old data and paste the script we have. And let's close it again and Ctrl-Shift-V to paste it all. We're going to have to delete the lines that are not actually Python. So if you want to delete the full line, you can do Ctrl-K like that to cut it. But I'm just using delete to get rid of these dots. So we have the pure Python code with 4 spaces indent for these. The code is very simple. We are importing the Modbus TCP client class from this library. And we're going to make a client here using the IP address and the port 502. Then we're going to do client.connect. But we put this in an if so that the response being true or false will print these messages. If it's true, it will say connected to PLC successfully. And if it is false, it will say connection failed. So now we do Ctrl-S to save and Ctrl-X to exit. Now we are just going to do Python 3 script1.py. And it will say connected to PLC successfully. That's great. We know that we now have managed to connect to the PLC over Modbus using the Modbus protocol connecting to the PLC on port 502. Let's continue with the next section. The next step is reading one of the holding registers, and we're again going to copy this text here. And this is the bit. Let's hop back to where we have the script and let's arrow up twice to go to the nano script1.py line. When we enter this, we go down to the bottom and we add a new bit. First, we have to paste it. So let's first clear so we can see that we get the new data. We can see Christmas presents and chocolate eggs here. So let's close that and Ctrl-Shift-V to paste. Again, we have to delete these extra dots. So remove these. So if we were not to do it this way, but to paste every single line, we would be doing it for even longer. So I think this is the easiest and quickest way to do it with the attack box. There, So all the bits are fixed. Let's read the code before we run it. We have result for client read holding registers. The address is 0 and we want to read one register and the address is 1, the slave number 1. So if the result is not error, if not, result is error, meaning if there was no problems. There is no else here, so we could make ourselves an else. Let's do that actually. Else colon printf. We got an error. So we will see that only if there's a problem. It's always nice to have full control and see if you get an error, not just not do anything. So if we don't have an error, we set the package type to the result of registers 0, which is a part of the result that we get, the data we get back when this function is run. And then we print out this package type. And if this package type was 0, it was Christmas presents. That was the save data in this register. And if it was 1, we have chocolate eggs, 2, Easter basket. I'm curious to see, I'm assuming chocolate eggs, but Easter baskets. Didn't someone say something about something else than a chocolate egg? Huh? Let's do Control S and Control X to X. Now we're going to arrow up twice again to run the same script. And this time we didn't just connect to the PLC successfully. We also got package type 1 and chocolate eggs. So now we have more information about this. We also have the name hidden under here. Let's hop back here and let's copy the next section too, which is reading the delivery zone HR1, and they have made an if of this too when reading the holder register 1. So let's copy this too, hop back here and prepare our data by pasting here, and then we arrow up twice to edit the script in Nano. Then I'm going to Control Shift V to paste the rest of this code, and there. And when that is fixed, we can Control S, Control X again. Arrow up twice and run. Now we know also that this is a normal delivery zone, and we can also see that it says HR0 here. So we have a nice, pretty printout of the data that we have so far, using a manual translation of these numbers to what data we have. And we got this data from the data that we got on the little note. This is the data that we have entered, this and this. So let's see, what is this? It is time for the holding register 4. They have entered the data here that if the signature is 666, it is exploit detected King Malher signature. This is something that we didn't know, but we learned it from their script now. We got the little hint here with the exploit, right? Let's copy this and hop back here, edit the script. So let's paste the data with a new King Malher signature. And let's paste this at the end of the file. Control Shift V. And there, let's Control S, Control X, and run the script. And as we might have expected, there was a 666 saved in this register called HR4. The script then prints King Malher's signature. Let's hop up, back, and start reading the coils. So you might remember that coils are a true-false value. 0, 1, activated, disabled, all of those versions. We have 10, which is inventory verification, meaning do this thing exist before it's trying to pick it up. And then we have protection override and if protection, because we get a Boolean value back for these, which means we don't need to compare with any values like we did earlier if zone is 10. Now we just say if verification, if not verification. So send for coil 15 if self-destruct status to know if it is already armed or not. Yeah, so not if it is self-destructing, but if it is armed. Okay. But it will be if we try to change HR0 once C11 is active. This is the trap mechanism. Since there is a complete reconnaissance script a bit further down, I'm not going to go through all of these steps, but we're going to run the full thing. So here's the self-destruct stated, auto-arm on breach. This is the information that we got from the note that was crumbled on the floor at the start. So it is not yet armed. And this is the trap mechanism that we need to avoid. So let's understand it better. HR0 is set to 1. So we're getting eggs, not Christmas presents. C11 is enabled, meaning it's monitoring for changes. And if anyone changes HR0 while it is enabled, C15 will get armed, meaning it will start its self-destruct, which doesn't sound that good, does it? Once C15 is armed, a 30-second countdown begins. After 30 seconds, C12 emergency dump activates, and everything dumps to zone 10. And this we didn't actually know before now. We just got this information here. Now we have the full reconnaissance script that we can copy from here. So we don't need to add all of the code manually. I'm just going to read through this. I will not be long doing it. So we have the IP address and the port written down as variables instead. This line is exactly the same. This is called a shebang, and this makes the command line or the shell in Linux understand what script this is and what program to run it using. So it will start Python and interpret this using Python. That is what this does. If we set it to be executable, we can execute it that way. Let's do that. So the first line we recognize, but now we have the variable names instead of the data itself here. And we also check that it did connect, otherwise we exit the script. We print 60 equals messages to get a little nice header on the thing for reconnaissance report. And an empty line after that. Read holding registers. A little line again. And here we have read holding registers, address 0, count 5. So we're actually reading all 5 here, and to the same unit ID, the slave number 1, which we have had all along. So if there's an error, now we just have this once instead of lots of times. And the data that is written out now is the HR1, HR2, HR4, and these are gotten from here. As the count is 5, we get not one thing, not one bit of data, but we get all of these. So this is a nice feature of Python, that you can put variables with comma when there's actually several bits of data in here. Now we don't have ifs, but we have just an explanation of what this number that it will print out is. Here we have actually an if with an extra warning that it is detected, an exploit signature. So then for the coil read, which we haven't done in our script ourselves, it does instead now read coils, and it reads the address number 10, that's where it starts, 10, 11, 12, and it reads 6 of them, from 10 to 15, and the same ID. Checking that there's not an error. Yeah, colon 6. I'm curious about that one. Yeah, so as now we're dealing with bits instead. We have to say that there's not a full byte here. Or we would have had to have more, I guess. Then we print these bits. And as we saw before, they will probably print as true false, not as a digit. Should be true. A system monitor for changes. They have the ifs here. if C11 is true. So if it says if C11, that's the same as if C11 equals true. And system monitoring, done protocol active, and the audit logging. We want it to be logging, right? Then for Christmas restart, auto set when system is fixed. Okay, so this one we don't set, so the system sets it automatically. And then the self-destruct. Countdown active, so if we were to mess it up, we will see this danger warning here. And we'll have to hurry, I guess. Print, a little nice sign again with equals lines. And then we have a combined bunch of if messages, combining all of the data that we have had earlier with what we have read. We will see if exploit framework is detected, if protection mechanism is active, trap is set, we need to disable it first. And the package type is forced to X, we will see, and inventory verification disabled, we will also see, and audit logging disabled. Remediation required, it prints whether or not we get any problems. Okay, let's copy this text and run it on ours. So we're not setting anything, we're just reading data, so it's all safe. Copying this, hopping to our little virtual machine, and putting this in the clipboard. So, and let's actually nano something else. Let's nano, call it recon. Recon.py. And we're going to paste the full script. We already read it. We can just check that it looks like it's complete. That's a nice thing. And then we do Control S, Control X. To be able to run this without using Python 3, we're going to do chmod on this. So we're going to chmod plus X to make it executable on recon.py. There. So now it should be executable. And then we don't have to type Python 3 and the script name. We can do /recon.py. There. And it should run and give us this full report, which always ends with remediation required. So we have 1 for X, we have 5, which is a normal zone. We have exploit signature detected. The Boolean flags, they are C10 should be true, and it is false. We have no verification of things before they are moved off. We'll have to fix that, right? And then we have C11, protection override true, meaning the system is monitoring for changes, meaning we can, if we try to change anything, mess stuff up. Emergency dump is false, audit login is false, but it should be true. Christmas is not restored, it's false, unfortunately. Or I guess it wouldn't be fun if it was, right? And all of these lines are also, all the checks are like not fixed yet. So let's hop back to actually remediate this in a safe way. And then we have to think of the order in which we do things. And they have said it here, so maybe we don't want to read this. Maybe we want to think ourselves. It is not that hard, right? We need to first disable the protection mechanism. Very obvious, right? Then we have 3 other settings that also need to be fixed, and one that should set itself when we're done, right? So we're going to copy our script 1 as it has a connection, so we don't have to rewrite that. It's time to restore Christmas. If you want to, you can just copy and run this script, but I'm going to show you how to make your own. We're going to make one change at a time, and then we're going to run the check script that we just run to test the status. We will just fix it so it doesn't always say that remediations are required. The one thing that we need from the script is to know how to actually write data. So let's scroll down. This is the read that we have already been doing. They have just put the functionality in functions. So here we have the line that we need. So we copy this, and we're going to hop to our little machine. So the attack box is ready, And our recon script will show us most things, but at the very end it will always tell us that remediations are required. This is where we need to make a little change. Let us write if what was the one for Christmas is restored. Let's check that one out. Christmas restored C14. So if C14 is true, then the system is fixed. That means that if not C14, then just checking that I get the right amount of spaces or Python will not be happy with me. And then we do else, colon, print. I guess we do uppercase. Christmas saved. There. Christmas saved. Control S, Control X again. So let's go up and run it again. And it still says remediation required because we didn't fix it. Let's now look at the directory. Actually, let's ls. So we can see here we have reconpy, which is executable, while script1.py is not because we didn't make a shebang line at the start. We're going to copy script1 so we don't have to retype things. We're going to cp script.py to save.py. We're going to save Christmas. Then let's nano save.py. And this is our basic test where we wrote out the information. We don't want all of this. The rest after this is not required. So I'm just going to hold Ctrl K to cut those lines away. That's the easy way. And then we're going to just add the results equals client dot write coil, and the parameter is 11 because we need to change C11 first. Let's go back here and check C11 is the protection override that we need to change first, right? If you don't change this first, we'll get problems. So we need to set this to false, normal operation, false, and slave equals 1, as we have done all the time. And running this line, we want also a status on how it went, right? But we can check that later, so we don't really need it. I'm thinking we'll do Control S, Control X, and we will run this Python 3 save.py. And we just saw the connect line because that was all we printed. But if we now run the recompy, we see that C11 is now false and we're not getting that warning. We only have 4 lines instead of 5. So the first thing is done. Then we go back to our little nano save pi. We could comment this line, but if we write the same value again, it won't matter. So we can just extend this, is our little save fix here. And change package type is the next one we want to do. We also want to enable the inventory verification and the audit logging. So we have all the things. Do we want logging first? Do we want the other ones first? Let's do them one at a time. We don't really need the result in this case either, so we can just have this line. I think the easiest way is just to copy this and paste it, and paste it. And the values we want to set here, so we want to set 10 and 13. And this one is actually, let's see here, HR here. We want to set to Christmas too, so we need to change the holding register. Let's see, we have write coil. Here we have write register, so confirming. We see that this uses 0 here too instead of false, true. So we need to set the value, of course, and Christmas happens to be 0. That's why we're setting 0. So instead of write coil, we do write register, and it's the same kind of parameters. And so this one needs to be register. Write register, and it is the first one, 0, and the value is also 0 for Christmas. So checking, holding register 0, set to Christmas gifts, right? Let's also confirm all the others. We did this one first separately. We wanted to make sure that this was already set before we made changes. 10 and 13, let's confirm that these are the ones we want. 10 is inventory verification and 13 is audit logging. Let's go back now to this and actually save this, because if we save this, we can read our thing. And let's make sure that all of these are set. I know that we didn't set this one though. So the package type, the inventory verification, and the logging. These three should be gone if we run it now. Maybe we want to set this too. The default value we knew from this file, right? So let's see here. 100 is the default for HR4. So we can just do this. So instead of 0, we do 4. Instead of 0, the second 0, we do 100. I think that's the last bit that we need to add to our nano save pi. So we're going to copy this line, Control Shift C, and then I make sure that I'm in the right position, and Control Shift V to get the new line. And we want 4 and we want 100, right? That was the default values that we read here. So I think we are done. Control SX, we run the save pi with Python 3, and we didn't print anything out from this because we can easily confirm if it worked or not with our recon. And inventory verification is still disabled and audit lock-in is disabled. I'm thinking we set them to the wrong value. That's what we did. So now we nano save pi and we double check the values. We set them to false. What we needed to do is to actually enable them, not disable them. I just changed these numbers, right? So 10 should be inventory verification and 13 should be the logging. So these two actually needs to be true. There. True. So we save, Control S, Control X, we run Python save pi, and we run the recon to check it out. And now we got the message Christmas saved. Let's hop back to the room and see what they did. And if we have any questions to answer. Right, we could have triggered a tab. Right, we need to check the web page, of course. So let's go up here. Here we have our running Firefox browser. Oh, look, it says system restored. It looks like it said kaboom there, but it says system restored. Interesting. Ah, look here, read the flag from registers. So after we got this, we also need read the flag from registers. Address 20, count 12. So this means that we're reading 12 registers to get the flag. So it is probably more than one character. So we're actually going to copy this bit and let's put this in our save because that's the most relevant spot to do it. Let's nano save pi and let's add this last bit here. There, so we have the code copied into the clipboard. Control Shift V to paste. And as this is Python, it cares about indentation, so I will just remove these spaces. So flag result, the result from trying to read the flag is client read holding registers address 20, count 12. And this one needs to be set to 1. So let's change that because we don't have a variable. There. The value of the variable was 1. If there's an error, if there wasn't an error, flag bytes reg in flag result registers. You don't have to understand this. It messes a little bit and appends to the flag bytes array that it created here. So it's doing binary operations on it, and then we are joining all the bits into a flag that we print. and just Control S, Control X this now, and rerun this. We get the flag. So the only thing that we needed to do was to read this flag, egg mess over. And I think that it will actually copy when we select the text. So we're going to paste the flag here, and it worked. And let me check that. Nice. And if you enjoyed today's room, feel free to check out the OT Challenge Industrial Intrusion. There. Thank you very much for joining me doing day 19. And don't forget to finish all the rooms before the 31st of December to get a chance to win the amazing prizes. We have all the cool things here. Bye-bye.